The problem you see here has a delightful sort of symmetry to it. I think it's been getting a lot of airtime at various channels um, as a Cambridge entrance exam question. But I'm just going to write down some of the properties I used right here. Um, and I'll leave out a lot of it. Most of the steps are shown. But this is, of course, the well-known result of exponents. If you have m copies of b times n copies of b, you have m plus n copies of b. And that's easy to say because multiplication is just symbols juxtaposed, right? With an implied operation, of course. So that's what happened going from here to here, okay? And then right here, there's just some division. We divided through and got the x exponent isolated, okay? So we got this far. So this first line is equivalent to our original equation. Now, this next line, I factored a 1/5 out, okay? And the reason why you get to use the product property of logarithms. And also I use the fact going from here to here that exponentials and logarithmic functions are inverses. So in other words, b raised to the log base b, and really parentheses belong so that doesn't look like a b to the x, but this is understood to be in parentheses as a function. This is equal to x. All right, and that's what I did right here. Well, actually, it's the opposite of that. Okay, I should have written log base b. Yeah, I used the opposite of this to get this. I took the logarithm of both sides to get x isolated. Let's see, how would we write that? Log base b of b to the x. And a similar argument, and technically you probably need parentheses here to remove any ambiguity about what this actually means, but it's used so often, the parentheses are left out so often. But that's what I did to get from here to here, to strip away, to get this x in a workable format, okay? And the base here just happened to be 5/6, okay? So there we go on that. Now, these other properties are relatively, I won't say too much. Again, this is the product of two logarithms becomes, the logarithm of a product is the sum of the logs. That's what I used right here. Now right here, a similar thing, the difference, the logarithm of a quotient is the difference of the logarithms. You see this minus sign right here? Also, there's, if you think of this as a minus plus all of this stuff, that just means you have 6 copies of 5. And that, again, that's the sum to product law, all right? And so if you just carry on here, it's fairly straightforward. What do we do right here? We have this is a difference becoming a quotient, okay? So we have an answer in terms of the logarithm base 5/6. Now this is an answer, albeit you don't have a 5/6 base button on your calculator, but if you want to, you can go ahead and take the extra step here and just do the very well-known change of base. We can do log base 10. I won't write that down. I won't write the 10 down, but you could write down the log of log actually means ratio, I think, if you go back to its etymology. But you can write down the log of, and we have enough room to use parentheses here, 6/5 like this. Okay, and again, y'all, this is called in your algebra books change of base formula, divided by, because we're changing it to a base, and almost this is a definition of logarithms if you really look at some of the old timers who present mathematics. You can almost define a logarithm just like this as a ratio, and I think it was done that way years past. Okay, so you have 5 raised to the 6 here. Now again, the benefit of this is you can actually substitute this in your calculator and get a decimal answer. I'm not going to go to the trouble to do that, but this is called the change of base formula. You could also do that. This could be the natural log or any log you happen to know how to compute. The standard buttons on the calculator are log base 10 and log base e. But anyway, this is the final answer. I didn't go to the trouble to write down the decimal for you. I'm not sure what it is. Okay. Now, something I attempted, so this completes what I was trying to show you, but something I wanted to show the rest of you who want to care to stick around and listen. I tried to check the exact answer down here, okay? And I got this far with it, and the symmetry should indicate that this, but I can't figure out why these two things are, they have to be, because I have gone back and double and triple checked this answer. So I know this is right, but when I actually tried to check the exact answer, not the decimal, here's what I got, and I think it's correct up to here, but it's not clear to me why these two things are equal to each other. Let me know if you see why. Okay, that's the answer. Thanks for viewing.